It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 387. At what rate is the volume of a cube changing at the instant when the surface area is 54 square inches and each edge is decreasing at the rate of 0.5 inches per second? Okay, we'll start solving the problem by drawing a cube. So here we have cube, right? Okay. So let the edge of the cube be x. X here. Okay. The question is to find the rate of the volume of the cube when the surface area is 54, right? And it is also given that each edge is decreasing at the rate of 0.5 inches per second, right? If edge is decreasing, the rate must be negative, right? Think about this graph right here. Let's say this is time t, this is edge x. If this is decreasing like that, what is its derivative? I mean the sign of its derivative. Its derivative is negative, right? So this must be negative, right? So let me erase this. So it is given that dx over dt is negative 0.5, negative 1 over 2 inches per second, right? So far so good. Here it is also given that surface area is 54. So surface area. Surface area is, the area of each face is x times x squared, right? X squared. So we have 6 faces. So that's 6x squared. And we're going to find the rate of a volume when this is equal to 54. Okay? So the volume, the equation of the volume is equal to base times height. X times x times height, x cubed, right? So let's differentiate with respect to time t. So we have dv dt, change in volume with respect to time t, is equal to, we have to apply the power rule, 3x squared times chain rule, derivative of x itself, dx over dt, right? Okay. When the surface area is 54, then x has to be 3, right? So we're going to substitute 3 here. And dx over dt, that's given. That's negative 1 over 2, right? So substitute negative 1 over 2 for dx over dt, right? So our dv dt is equal to 3 times 3 squared times negative 1 over 2. So that's going to be negative 3 cubed, 27 over 2, right? What's the unit? It's volume over time. So cubic inches per second, right?